Hello. Okay. I will wait for you guys to confirm that we have good audio. So then I'll start. Uh, can you guys audio is fine now? So I'll just wait. It takes about 30 seconds for this to loop through as we're streaming directly to YouTube. Okay, thanks. So then we can start. Yes, in the office today, not at home. Okay. So, okay. So the idea today is that we will um, live code a character controller. So I'll explain a few things behind about the motivation for this and so on. But besides coding a character controller directly as code generated components and in project source code, everything, not reusing the internal CC. Um, besides that, feel free to ask any questions, right? So you can ask questions about quantum 3 in general, you can quantum 3, you can ask questions about quantum in general, or even what is difference between 2 1 and 3, what are our next plans, whatever you fancy. But not only quantum, it's also fine to ask stuff about fusion if you feel like it. So just ask. So that's the thing. So I'll be mostly coding, but of course, you guys are free to ask anything. I'm not sure. I mean, of course I cannot promise to answer everything, but I'll try my best. So let's see. Let me check what you guys have written already here. So audio is good. Office. Okay. Okay, all good. So let's start. So I'll switch here to watching the scene. Oh, I go. This is wrong. Let's see. Okay, desktop scene. So I have to fix something here. So let me see if I can, because it's seeing just part of my desktop because the desktop is a bit bigger than the stream resolution we're streaming at. So yeah, we're streaming at 1080p. I have to reduce the. Okay, now we have the full scene here. You guys have all my structure here, but I had cleaned it a bit, so this is nicer. See today. So let me just make sure I can check if there are questions. It's all good. So can start now. I'll also, I mean, we have some of the guys from the team watching this. So if you guys ask questions also on Discord, um, we'll be taking a look, and I'll be probably warned by my colleagues. And so feel free to ask there as well. But of course, it's better if you ask here in the chat. Okay, so it's gonna be we're gonna go straight to quantum 3. So but I'll start with the basics because this is really a clean project. So let's switch the dock here for quantum 3. I'm actually doing like everybody else, and I will download the current latest build we have, 1294. I think I was coding yesterday with 1293, which was the one from the day before. So let's do this. But it's just a Unity package. It's downloaded, it's ready. So what we do now is we're gonna create a new project. I'm gonna use 2021 LTS. It's not the latest, but it is one, a valid one. So I'll just get a new one here. So and to see all that, and name of it will be free KCC, something like that. What is it complaining about here? 3D. But I don't need that. Oh, folder with that name? Okay, fine. Yeah, it's an official by exit. That's what it's asking with this new hub version. Okay, that's it. Let's create this project and then we just go straight and import the Quantum SDK, which is now just a package. So, well, I'm doing this live, so we have now to wait. So while we do this, you guys can see my face instead. Just have to wait until it starts. This is a nice rig here. So it's an i9 13900K with a 24 cores, 30 through 32 logical cores. It still takes this much to create a new base project. And this is not Quantum yet. This is just Unity still. Is what it is. Okay, so we have a clean Unity project here. Let's just import custom package, which is just grab Quantum package here. So it's very clean. We did this yesterday. It's just import everything. In this case, it's the first time. It shall open the Quantum Hub. Then we have to press install for it to create a few initial sample scripts for you on the first installation. Then it asks for an app ID for us to do stuff online. I'm not gonna do the app ID part right away because it's not strictly necessary. We'll do it when we want to test it online. Here it is. It's already asking for that, but I'm not gonna do it now. So yeah, everything is cleared except for the app ID. I'm not gonna do it now. So you have a clean console, no errors, no nothing. I'll just enable everything you need. So okay, Quantum comes with a few nice. So let me import Text Mesh Pro, so the menu is gonna work. I don't think I need example extras. Yeah, I noticed this yesterday. First time you import TMP, it does not get the fonts right, but once you play it once, it starts to work. Res, good. So we have the Quantum manual working now. So this is a cool thing that we brought in Fusion 2 and Quantum 3 as well. So we have this default menu that does for you the most common use cases. So it has a way for you to create private rooms, and when you do that, it generates a 6-key code that you can share with people, and then people can come here and join by pasting it. And it shows a lot of little things that you can organize the settings. So I think you can fix which version of your app this is. So you can specify the region you want and a few other things. And this is nice because this is the same one in Fusion and Quantum. So it has a lot of, let's say, common things. So you can define a nickname for your character. In the case of Quantum, this is gonna be used on when sending runtime player with a nickname and a few other things. So uh, yeah, it was trying to connect to Quantum, so the error is about, I don't know what I clicked at. Oh yeah, when we go to party menu, I think it tries to. No, that was not it. Maybe it was the best region select. It's not. I didn't put an app ID, so it's complaining about that. But don't worry. You can also select the quantum enabled scenes that have gameplay. So when you publish this, you will let people choose which game, let's say game mode or game scene to play. So it's very convenient for most use cases. I recommend you guys trying this. So let's go straight to the game scene. And anyway, the topic here is character controller. We're not gonna waste much time on this. I'm just checking if I have questions or oh uh oh okay this thanks Ramon fixed. I forgot to show Unity's screen. Damn it. But I'll open again here so you guys see. So we have the Quantum Hub thing that was used that opened at the beginning. I clicked install and it did the installation all cleared. All passes were done. It specifies here what it did for you. So the stuff that it creates and tests. We just didn't add an app ID. And I was showing how the Quantum Vault menu works, which is pretty nice to do party or on the settings you can select a lot of little things. You have this both in Quantum and Fusion. It's very convenient to use. We do recommend it. And yeah, the menu tries to connect in a few situations. So because I didn't put an app ID, it's complaining here, but this is easy to fix. Just put an app ID on the Photon settings. I'll do this later when we actually need to test that. Photon server settings, you can paste here the Quantum app ID, but I'm not gonna do it now because there is no need yet. Let's go to the topic. I'll just check if we have some questions. Um, yeah, I fixed this already, so you guys should be seeing that now. Okay, so the topic today is character controller. Um, so let's start. Let's go to the gameplay scene. Let's place like we did yesterday. So I'll create a quantum 3D static box collider that I will, oh, not game scene. So I have this guy here. I'm gonna make this guy big enough, 5 or so. So the collider is big enough here that it works. But I'm also gonna create a material. So quantum user. I'm not bothered with performance of the final build yet. So I'll do some stuff that is not optimal. I always do this, you guys. So I'll call this floor material. I just want to have textured checkered pattern. Find it somewhere. Yeah, all checkered. And I'll tile it like 32, 2. Then we can drag and drop it here. We enable again renderer. It has a nice checkered pattern. Enable the gizmos to check, and this is going to help us see what's going on. So if we create here we can try to get the quantum prefabs that we have pre-built here. So you see that there is a character controller entity that you can add. So you can create a prefab for this. So this guy comes with an entity view, and it comes with this default character controller that has a default character controller config, and this uses the internal code. What we're gonna do today is we're gonna take a look at the code of this guy, but we're not gonna code it. We're not gonna use the pre-built one. We're gonna ditch this. No, we're not actually gonna even use this, but we're gonna take a look at what is the code like inside the code of this character controller. I'm gonna open the code here of the internal SDK, and we're gonna copy it and actually make it work in a more flexible setup, which is in source code. You can do the whole character controller part in your own project. And the reason I'm doing this now is because if you guys have used Fusion, in Fusion we have the KCC add-ons. So there is the basic and the advanced character controller. And these are very flexible, extensible, and they come in source code. So this is the idea for Quantum as well. We're gonna move forward by creating a Quantum character controller add-on that will be distributed in source code. So you can extend it, take a look at how it works, and create your own. And what we're doing today is basically the embryo for this. So it's the basic version of it. Let's see what we need to do. So first thing I'll do here, so let me check if. So I'm gonna be using Rider for the main code here that we'll do, but I need to open the project of the original Quantum sources. So I take a look, I grab the code from the actual Quantum internal KCC. So let's just make sure I'm on the right branch here. I am. I'll make sure I have latest. Then I'll open the code and we'll take a look at how it looks like. So we have it exactly the same code as we have on this build here. And I'm gonna open the Quantum sources directly. I'm not gonna show everything, but we'll open what matters. So for curiosity's sake, so this is actually the source code of all the internal stuff in Quantum. That includes even the, take a look at something cool here. Even the Quantum code gen. So you see the code generation that Quantum does? This is all it is. This is the compiler. It's written in F sharp, which is a functional language. It's a pretty cool code that's rock solid and it's easy to maintain, and it's what does the QTN magic. But we're not talking about this today. Anyway, just a curiosity. So let me grab here just the character controller code. I'm not gonna show all the stuff. Let's go straight to the stuff that we can share and that we'll do. So the character controller 3D has two parts. So it has the main character controller component and some configurations it uses and so on, and the query part, which is where we're gonna start. So the query is the implementation of doing a shape overlap at the environment and checking if you're colliding with something, if you are touching something, and then computing what should happen with your character controller given the surfaces you are touching. So think about it like this: if you're not touching anything and have gravity, the thing is just gonna return to you, hey, you're not touching anything, so probably you are in free fall. Or if it detects that you're touching something that is underneath, it's gonna tell you, hey, you probably, it's either on a horizontal movement, here's the surface tangent, if you're past an intentional direction you want to towards, or it may just say stay where you are, and here's, by the way, a correction vector for you to depenetrate a bit. So it has these things, it detects slopes and a few other things, but it is just a query. It doesn't modify the internal data of the character controller at that query. It just queries the environment. And this is the one that is done currently with a sphere. And now that we added a capsule, okay, we had a small disconnection. Quick action back. Okay, so I will not waste a lot of time. So basically, what we'll do is we're gonna copy this code here, and we're gonna implement it by changing the. So this is the version with broad face queries. We're going to ignore this version. We're going to use the standard shape. And what we're going to do is, instead of using a sphere, we're going to port this to use a capsule. I already tested this because I ported this code for Quantum Unreal using a capsule. And I know that most of the algorithm works as it is. I don't have to change much of the algorithm itself. So we're going to keep it basically as it is and just replace it with a capsule and test how it goes. So this is the first thing we're gonna do. But I want to do something else, which is um, the this built-in KCC has a configuration asset that's used both for the query and for the movement. I'm going to split this into two different configuration assets because I really want to decouple the query part from whatever you want to do on your own KCC for movement. So I'll go ahead and so I'll simplify a bit the configuration. So we're going to copy that one as well. So this is the source that we're going to use as reference. I can move this guy aside because I'm going to copy from it whenever necessary, but we'll now start coding our own. So now what we're going to do is, because we're going to split into different things, let's organize a few things here. So I'll create a folder for our QTN files. I'll create another folder for our assets, or maybe we should organize based on feature set, but this is a personal choice. So I'm gonna organize like this, and then I'll create a folder for when we create systems, and that's where we're gonna do things. So I'm not gonna create a character controller yet, a component. The first thing I'm gonna do is I'm gonna create the asset that has the character control, the query settings, and then we can even implement the query itself as part of the asset. That's a good way to do different variations if you want to. So a quantum asset is just a C# script now, anyway. So let's call this character controller query 3D. Oh, character controller query. Oh, uh, surface query settings. That's the name of the thing. Let's open this in Rider and start. So I have a bunch of people watching. You guys don't have any questions? Okay, so let me make this slightly bigger font. So, hey, we're not this. So, no, not Unity. I don't care about this. Not gonna use this either. And I'm gonna put you on namespace. Boom. Oh, space. This guy inside. And I inherit from asset objects. Okay, partial. This should be enough for it to generate the code for this as an asset. And we can test by checking if we can create query. Does it show up in here? Not yet. You have a problem with CodeGen? No. Runtime? No. What did I miss here? Find one. Oh, of course. Forgot one thing. So for an asset object class to have all its code generated goodies done, we need at least one QTN file, and I'll call it character controller 3D. Call it that. open it in Writer. So I have to define that this thing, this class here, asset. Forgot to do this. When we do this, we inform Quantum that should co-generate stuff for this guy, and then shall show up in here. Where is it? Not yet. Surface query settings. It is. So we can create assets for this type now. But we don't have any data in it yet, so let's copy some important stuff. So let me grab the original settings and we'll modify it to have only what we need. So we had this struct called the settings. Here. This is what we need. So I'll explain stuff I'm adding here to import to use photon the statistics. So let's see what we have here. So I'll keep an offset from where the center of the character is, but I'll modify the default to be 0, not 0.5. And now because it will be a capsule, we need to have a radius, and let me confirm how the I think it's if we modify if it's necessary, but I think it is height. It's not extent. It's height that we use for a capsule. So I'll make it default 2 meters by 50 centimeters radius. We can modify this. We'll keep max penetration. We'll keep penetration correction because these are all used in the query. Notice that I don't need to use all this for the movement, so I'm just keeping the stuff that I need for the query part. These all are needed, so max context is still used. Layer mask is cool because it lets us define which one the query cares about. Use main fade normal as well. Air control, I need to check. I don't think air control is needed for the query. Same for acceleration, braking, jump, impulse, max speed, gravity, max slope, and max slope speed. Max slope is part of the config, yes, it here. But the rest, it actually looks like it's only for the character controller itself. So I'm not gonna use that. So same will go for gravity. It's same for this. Let me see if there is anything. So we just clamp penetration correction. These two we can delete this later. So this is the stuff we need for the query only, and we ignore these others. We're gonna move to a different setting object because it's gonna be for about the movement part, which is the second part. So let me, as always, check if questions. No, it's all good. So let's see how it looks like now if we create one of these assets. We're gonna create a folder here from assets as well. This is for where we have the assets themselves, not the classes. So we can create a quantum surface query settings, CC query default, whatever. Here it is. It's all created everything as a quantum asset. We have all the that you expect, and everything is looking correct in Inspector. So let's move ahead and now port the code. But where should I put the code? So this is about it's a query, right? So it does not really modify the game state of the character controller. It does not need, it only needs to know the current position of the character controller and the direction you are trying to move towards to compute the surface normal. So what we'll do is I'm planning to actually move that method here to the asset itself. So if you want to use asset inheritance, you can slightly modify the behavior of this method. So let me take a look at the code itself, which was originally implemented in the character controller, and I'm going to move it here. So there are two variations of it here. Let me take a look. What is the difference? Oh, it's just the version with frame thread safe and the version with frame. Um, it's because it can be done. Okay, I'm gonna keep both because they are, so we can keep frame thread safe version because it is good for doing, if you use this in parallel, it's already going to support it. So I'm going to copy it as it is, both, and we'll see what we need to fix it to work from inside the asset instead. So okay, I'm copying the whole code. We're going to simplify a lot of the code because there is a lot of code that is hand inline. Mistake here. Okay, let's move this whole code here and then we fix it as needed. I didn't query. So transform 3D, so this whole thing needs to be unsafe. Safe path. So why is it show? Why is it find correct? So this one is compiling fine, which is the version that we are gonna use with regular frame, this single threaded version, but it just uh, pushes it to the it just uses the overload that is based on thread safe frame, which is the one that you use when you're using our task system. So let's start just cleaning up this. So actually I'm gonna keep the same parameter list. It doesn't need to change at all. Can I make rider use more lines here? Other yet? What is it complaining? Oh, see, I don't have an raw parameter. Dot text version. I'll just compare the whole thing. Oh, oh, it's because raw is internal. We don't expose that. That's why. Okay, it's fine. Colliding with self, we ignore. That's nice. Okay, so actually, the query works as it is. We don't have to change anything. I mean, we can move the code to run from an asset and it works as it is, but we want to modify it to work with a capsule instead of a sphere. So I wanna do it from here. So oh, it is still receiving the character controller itself. So what is it using from the KCC itself? Broad face query index essentially. Um, honestly, I'm gonna ignore this part because can later edit back. And the reason for this is because I don't want to receive KCC. I want to simplify the parameter list. So because we don't need the KCC to do a surface query. We only need the current. We want to know who's the entity is. We know its transform, the direction we want to go to. Yeah, we'll have callbacks and other options optionally, but the we don't need to know the KCC itself. So I'm going to remove this guy from the parameter, especially because we're going to be creating a custom version of the character. So see, it's checking config here, but actually config is self now because it's the asset. We're implementing the method in the asset. So let's refactor that as well. We don't need this. The logic is here. So we'll essentially, let me be smart. Find, find dot replaced by nothing. Because, so we do need gravity and gravity normalized. So I forgot. I thought that would not be needed, but it is. So let's just need gravity. Then we uncomment gravity normalized, gravity strength, because these go together. And then we can pre-compute this too at loaded. Great. Why is it complaining about offset? Oh, sure. These methods were originally static. They are now method objects. Okay. Okay. Cleared most of it. We only have now the option of broad face query that I'm gonna remove. So there is no option of broad face query. And then we'll do a regular overlap shape. So and we're back compiling everything. So I could honestly just use it as it is here, but we can go through the code a bit so you guys understand what it does. Let me just check around here to see if I have any questions from places. Oh, it's all good. Okay, so what this thing does is it does an overlap shape. Oh, sorry. Before I comment the code, we are still using a sphere. So let's change this to use a capsule instead. So instead of a create sphere from the shape, let's create, I think we can just do shape 3D dot create capsule, and the parameters for creating a capsule are radius. Oh, it's extent, it's not height. So I'm gonna use height divided by 2. We will not use a position offset because we already used an offset before the query. And we were not going to use any rotation offset. Okay, yeah, we'll just use then create capsule here with query radius. And the second is height. Oh, divided by 2. Oh no, there is a difference here. So because query radius is the radius plus the extent. We have to do the same for the height. So but we're dividing that by 2 and then doing. So let's do FP query X. It's not query a capsule extent. Caps extent. So it will be height divided by 2. And then I'll add extent. So this is part of the way the query works. It queries slightly bigger than the query size you define because it wants to detect that you touch the ground even on slightly bumpy surfaces, and it does not change the grounded case very often. So it gives a lot more stable results. So this is why we use this extent thing. So we use this guy here when creating the capsule. Not be height of 2, it will be this specific extent, and that is it to replace the query that was a sphere with a capsule. Um, we're not doing any drawing, but we can check. I think we're not doing any drawing here. I think the original character controller does with has a gizmo for it. So let me see if I have questions. Okay, good. Checking this. Okay. Okay. Okay, so I think I'm ready to test this, but I want to just go through the code just to explain a few bits for you. So this is handing line in the code. So the original code was offset position is basically a vector 3 position plus an offset. So we used to do this a lot. Um, this is still optimizes better than IL2CPP handing with automatically inline stuff. This has been becoming better with time, but when we first did this, it was basically mandatory to do this kind of thing. So we would create a vector 3, but instead of just doing the operations directly, we would always use the internal raw value because that is slightly less operations when compiled than doing the regular FP. You should not worry about this, but on internal stuff, we always do this kind of thing. So sometimes we have when we do so additions, we add directly the raw values, the internal FP values, and when we do multiplication, it's cool the way we do because we try to find a multiplication example here. Yeah, so so we multiply values and then we do this shift. It is and this is doing with a nice rounding operation and so on. So it's similar to what the internal multiplier operator does, but it's done manually. So it's slightly faster than letting the compiler steal. Anyway, let's just go through what it does here. So we we define the position at which we're going to do the query based on the offset from the current transform that you are passing, and um, we define the shape. It's going to be a capsule. Then we perform a physics query with the layer mask that you defined on the config. So then we loop through. So we sort these guys to see which one is closer to the center, and we go through these based on the closest contacts first, and we compute we either use the manifold normal that comes from the contact itself, or we compute a manifold normal in direction to the center ourselves, which I tested already even on the capsule version, and it works really well. But normally, we would use manifold normal, and it works well. Um, yeah, so when it's a triangle, we do a special treatment, so we don't check back faces and a few other things. Then let me check if I'm already skipping. Yeah, we skip if the query is hitting ourselves, so we don't care about self hit. few other things we do here. Um, so then we start processing the thing. So this is just a pre-process of the hit we found. So if it's a trigger that you touched, these guys do not interfere with movement, but you may want to have a callback to react to this thing. So we're gonna redefine the callback for this, but for now we are reusing the callback type that was on the other one. So we can try to do it different. But so a trigger never affects the surfaces, so it's basically, but it lets you know that you contacted something. Then when it is an actual contact, um, we pre-compute some stuff and then we check if you have a callback, because if you have a callback and in your callback for the solid contact you say, oh, you return false, you are saying do not use this contact, do not take into account this contact. So in this case we continue, but if you don't do this, we'll actually let it process and go forward, and that's where we compute the tangents and all this stuff. But again, this is just the query. The point is that this query is good. It does. There are things that can be improved, but it is generally a good implementation for a query, and we'll we'll leave it as it is. We just modified it to use a capsule, so we'll not modify it further. What we'll do now is we'll create a component and a system to test what this query is doing. We're still not gonna what how do I mean? I mean, we're still not gonna make any movement code, but we'll perform the query and see what is the surface tangent it is returning. So to do this, so we already have the character controller here, so we can start creating a component that I'll call custom character, or we can call it custom KCC 3D character. Um, I'll need to have asset ref for surface query settings, so it will hold the reference to the surface query settings. You can have different settings for the movement, but for the query we use this. I already know in advance that the character controller will keep boolean for grounded state. I'll have an FB vector 3 for the current velocity, and I'll have an FP for max speed. That can be modified if you want to allow max speed, different max speed from time to time. So I already go ahead and create the component with these things. But the most important for now is just to have this query so we can create a system that's going to filter entities that have this guy and they have this guy and transform and can perform the query itself, and then we can show the results of the query. But then talking about the results of the query, this is what this thing returns, which is so right at the beginning here. So we actually create a movement pack, which is this character controller 3D movement struct that is defined by the original character controller. I want to use everything custom here because I want to make sure this is all extensible in a way that you can modify them if you want. So I don't want to use the only thing I want to reuse is the actual internal physics queries. So I don't want to use this type at all. So I'm going to copy the original and we're going to create one that fits what we actually need. So let me take a look at I'll copy this struct and we'll modify it. We'll actually keep it as it is, but um, we'll use the new name for it. So it is a struct, and I'll put it here as part of the same file because it is used here. I'll keep the um, same explanations because it's the same thing, but I'm gonna call it a different name. How is the asset called? Surface query surface query result. I'll call it surface query result, and it is a public struct. Everything is public here. I still have to define this one. So what I'm gonna make is this guy return this instead. This query result, this guy returns same type, and it creates this type. So it is the same. It has the same data, so it's compiling fine. But I need one more. I need this guy also to be defined here because I don't want to use the internal one anymore. Everything is new. So we'll create this enum here, and surface query result surface. I'll call it surface movement type. Surface movement type, because then we can this guy here, and we have to fix a few places where it uses name, but it's because they'll all be located. Different types are used here, and it's all cleared. So everything is custom now. They're all public. So it shall show correctly even if we expose on Unity. And that's what I want to try here. I want to create a copy of this thing. Surface move, no, not surface query result. So this will be temporary. I'm not gonna. I'll call it last query result. So we'll always see this here on the state inspector. It's a nice way to check what it does. Um, it's not a visual debugging, but it helps. So just checking. So we have a query. Let's now finally create our actual character controller as a capsule. Oh, nice. I have something useful. Code. I'll open it again. Hope we don't lose everything. That was interesting. I have to report that one. Let's hope the files are saved. Well, I still have Rider open so I can. We lost the. We lost. We have the floor material correctly. We have our QTN. We have our asset file. So this is all good. Yeah, I think it's fine. Have the asset. Yeah, it looks good. Okay, so we didn't lose much. We lost the thing here, but we can create again. So 3D static box 100 100 and the floor material. Save this guy project. So this guy. And it actually generated everything. I don't know why it crashed in that case. So we should be able to create now our. So what I'm gonna do is I'm gonna create a capsule entity as an example. So this guy has a quantum capsule collider added to it, which is not necessarily what I want because I'll take now my time to explain this topic that is something that a lot of people ask about. So pay attention to this. So see this capsule here. A character controller is not a collider. So a character controller, it it in the way I think about it and in the way we design character controllers. So a character controller is a query. So it is a way for you to check how your surroundings are, and then you decide the movement you can do based on the intentions of the player. So essentially you have a shape, the shape of a capsule that let you know what you are touching, but that is not a collider. So that means that to have a character controller, you do not have to have a collider on an entity. You can do a character controller without a collider. So adding a collider to it is optional. What happens is, if you do a character controller on an entity that does not have a collider, you will move normally because you always ignore collisions with self anyway. But um, what happens is that if the other character controllers do not have colliders, when you're moving, you go through them because you don't consider them obstacles, because you do not see them as another collider for you to be blocked against. Whereas if you add a capsule collider to an entity that's also a character controller, it means that others cannot go through you and vice versa. So essentially adding a collider to a capsule to a character controller entity basically signals that others cannot go through you. Of course, you can also let people temporarily go through you by flipping layers and doing other or custom callbacks based on a temporary state of the entity. So there are many ways for you to allow for this behavior to be triggered on and off. But the point is, character controllers do not necessarily imply in the need for a collider. But we're gonna leave the collider here anyway for other reasons because it's nice to have colliders so you don't go through others. But it is totally game specific. You can do a character controller without collider just fine. And both our default internal and this neo version that will be in source, both will support the same thing. So if you guys have any question about this topic, just throw in the chat. But of course, I wanted to explain this right away. So here is our character entity that has already our capsule collider, but it's not important. What we need is to add our custom character controller that somehow is not showing up in here. So where is our UTN file again? So this guy, the component custom character controller 3D, why isn't it showing it here? Something is off. I'll try to regenerate here. So maybe that's what caused the problem. I'll save again. This code. Oh, it's always crashing. Help! What is causing it to crash? So let me see if I did something crazy here. I'll try to remove this. Oh, I know. This should not emit this error though. I'll explain what is that are messing up here. So this query result is a struct. This is struct here that is not defined in Quantum itself, so it is not memory aligned. So it is complaining, but it should not be crashing. It should emit a compilation error. So I'm going to report this internally, but I know why it's wrong. We can fix this easily. We'll have to move these two definitions to be done inside Quantum, so Quantum co-generates them with memory alignment. The reason I was putting this here is because I wanted to see on the state inspector, but it needs to be memory aligned for this to be possible. So it's an easy fix, but we'll have to open Unity again. But before we open, let's do the fix already. So we'll move this in num to be here. Um, just needs to be called in num in this case. Should do for the enum. And then this one will remove all the comments in this case, although the comments would still work, but they would not generate the, I don't think they they are moved to the C# generated file, so I'll actually remove 5 because we can also remove publics. It's standard in Quantum. We're considering adding the possibility for you to define private ones, meaning that they're always created with default value and you have to explicitly use it for code that you extend inside the struct. Uh, okay, I think everything here is bleatable, so it should be clean. I'll just extra lines here. Should be good to go. So it's not compiling anymore here because it's missing these types, but once we co-generate them, it's gonna work. So let's open Unity one more time, and now this mistake is fixed. So shall be good. Hopefully I saved everything in the scene is not gonna be lost. Should be able to recover. It is co-generating now, and it recovered. Yeah. And let's see if we can add the component now. So now we have the custom character controller because it generated it correctly. And here is the basic stuff. And we have a last query result, which is all zeroed out. And of course, we're going to be able to watch this. To see this, if we press play here, it is a static entity with a collider. It's not going to do anything. But we can take a look at the quantum state inspector. Let's put this guy here. I'd like to see it. So we can take a look at our the actual live values here, and we can see the live values of the last query result. And this is what we're going to be doing now when we add a system to go together with this. So we already have here folder for systems. So let's create a system here. I'll call it movement system, character movement. Check, yeah. Just checking that everything is still running fine. Okay, let's turn this guy into a quantum system. It's kind of like Unity creates this called skeleton here. We should create a skeleton for creating a quantum system. Namespace quantum. Let's bring this and already the skeleton for a system. That would be nice to have. Not sure if it's possible. So movement system is going to be a system main thread filter. So I like to create a struct filter with the I will go ahead and save, and it will have a public ref entity, public transform 3D form. I need a transform, and I need public custom character controller 3D ACC. around here. All good. So now we can use filter type here, and it asks to implement the update method. I always move my update method up, and that's it. So now we have all entities in our game state that comply with this filter, so they have at least a transform and a KCC. They can have other components, but they have at least two, and I already get the references for them, the pointers. So what I'm going to do now is I can grab config equals frame dot assets. We don't have assets. It's like find asset of type query setting. Surface query settings is the type of the asset, and we use filter dot acc query settings. It's a type safe, the type safe asset ref, and I think this is redundant, right? Yeah, redundant, because this is already the generic version, so it already returns the right type. So config is already surface query settings. Yeah. So I'll just make sure config is not null. And remember, the query now is part of the config. So we can compute raw movement. That's the name of it still. So what do we have to pass in as parameters? The frame, the entity, which is filter.entity. We can pass in the transform, which is filter.transform. And then we need the direction. I'm going to pass default direction, which is, I'm not trying to move still. I'm just standing there. I'm just saying, hey, what happens if I use this as a query? And then that's the all for the required parameters. But this thing returns a surface movement. So what I'm going to do is I'm going to store on filter.acc last query results the result of this. So we'll just constantly query and see what it does. Of course, we're not moving the character. It will just give them one result, but we can place it around with a mouse, press play again, and see what happens. So this is the system. We just have to make sure the system runs after the physics system, and we should be good to go. To get the system in, we need to check in the runtime config here, the system config asset, because in Quantum 3, there is a way for you to define data-drivenly which components, which systems run. So I think physics is the number 3 here, which is the fourth. Have navigation, prototype, map entity, and the player connected. So let's add one more. Let's add one more here in our system. Movement system. That's it. Press save. We already have our entity here. Let me make sure project saved. And there is our character controller. I forgot this thing. So see better. So let's see what is the result. Oh, it's wrong. Oh, I didn't check what is the size of our. It's kind of. Oh, I know why. We forgot to assign an asset. It's not trying to find a default asset. So we missed this part. So we're not setting the query settings. So created one, but we didn't assign it here. So we didn't have the asset ref. Then this code here checks for null. It was just not executed. So now that we have a setting shall execute, and we shall have, yeah, here it is. So we get a normal. So the normal, it's kind of off to me because it's negative. So I have to check why the why it is doing this. So let me try to move this guy a bit up because this it's normally it's not. Although it should create a. Let's try to see barely touching here. Bug this a bit. Oh, now it's in free fall. Oh, this is the size of the. Take a look at our query. I think we need to draw it. See, so we have radius height 2. Okay, I think it's better if we. So let's make this thing show what's going on. So we should the query here. So can we draw a capsule? I can't believe we don't have a capsule yet. Daniel, Felipe. So we don't have a capsule on our debug drawings. That is unacceptable. So we'll need to. So let me see how we can simplify this. I can draw two spheres instead by using. Can use offset position. It's not gonna be then query radius. But instead of it's I have to use plus sorry, I bug offsets. I need to use the extent divided by 2, I think. Oh, okay. Okay, Felipe is correcting me here. So extent the capsule in C in itself is so height minus okay minus radius. So Felipe was fixing it to. Ah, okay. And that actually that lets us exactly use that. Oh, but I don't need this extent here in this case then. Yeah, I don't need this in this case then. And then I can just use this guy here to draw two spheres instead. Oh, this is a number. So up times extent. So I can use this two spheres to see how this capsule looks like. Thanks, Felipe. So, Felipe, it would be nice if you write these commentaries. You write these commentaries on the main chat. So let's see the debug drawing showing up here. Okay, at least I know what it is now. So, and on the state inspector, okay. Why is it saying we're in free fall? Should have known as movement. not free fall, because we're grounded. That's good. We have a ground normal, but we should have a nearest normal. So I think I'll have to debug what's going on. Let's try a bit more inside what it shows. Perfect ground normal, grounded true. I think there's something I have to do. Should use manifold normal when I use capsules. Aha, that was it. So that's I remember now when I ported this to Unreal. When using capsules, I have to use the manifold normal. So now it's going to work as expected. So we have the right, so the average normal and the ground normal is a positive y. There is no tangent movement because we're not trying to move in any direction, so that's expected. This is the penetration correction, and this is how much we penetrated. We penetrated only on one axis. If we add a second collider here, we will see the penetration and the correction all doing correct. So we are in a grounded state. We have only one contact. So that's correct. This is perfectly correct now. So let's add just one more collider. Okay, let's see. We should have audio back. Sorry, I think it ran out of battery again, but I have acted now. So this cable is not super big, super long though. It's okay. So okay, I can get this guy closer to me, and that helps. Yeah. Okay, so yeah, it is working. So let's finish the code now so we can actually see this um moving. We're gonna add inputs and control the character with that. So a few things I want to add here though. So I want to see full public bug and false by default. So I have debug, I'm gonna see that here. If bug, then we do this thing. Should draw surface normals and a few other things, but that's not the point yet. So we have ported our query now. So what we do now is we're gonna write movement code, and again we're gonna copy it from the existing code. We'll do a partial. We'll do a partial definition of this component here. So how is this guy called? Character controller 3 in. I'm gonna create a C# script called character custom character and the usual stuff. Namespace. Then we get UTN. Let's type here a partial unsafe struct. This guy. Save part. So we can add methods to this guy. So I'll go ahead here and get the movement type. So the movement code. There's another thing. So we have also the jump code, which is part of this. So set conf the in what init does. Oh, it sets grounded velocity. That conf. Yeah, okay. Okay. Yeah, there's a nice method to do that. So start copying the jump. It also has two versions of it. It has a type safe, um, thread safe one and a non-thread safe version. While still using both the. Oh, I already see that I forgot to add something that we had on the original one, so I'm gonna edit here. So grounded, then just jumped, stored. Let's let you in the code generate so you will fix that. Yeah. We don't need config ID. So I either pass an impulse. Yeah, we're gonna pass an impulse in this case for jump because I'm not so default jumping. Will not have a default. We decided to. So let's change the order here. Then we can make it default value. Let's ignore grounded. The ignore grounded is still letting you do double jumps and kind of thing. You want to control that kind of thing. So we'll always use the impulse. Don't need to have the code for the config. Stop raw value. Just to keep this super optimized version here. Oh, third order. Have questions? No, just Philip's answers. Good. So this is the jump code. So let's copy now the actual move code. Broad face query, which we're not now. Get layer mask. Move. Both the thread safe and the non-thread safe version. I'm gonna copy just the code this time. and I'll explain what this does. So system. So the normal move receives frame the entity direction. It does not need to get so optional callback layer mask use manifold to overhaul. I'm actually gonna remove all these use manifold normal for now. But it's gonna be it's gonna use the so for now we're using directly this here, but what we do on the move now it is um checking, yeah. Have to U type here. Oh, I either use this guy. I need this type here now. So now what I need. Oh, I'm not passing. So who's this KCC thing? Where do I get the config from on the get the config? Yeah. Oh, okay. Query settings. It's redundant. I don't need it. Ah, okay. Have to invert this. Post this type here, and I can inside this. This guy here. So I want to store it for debugging for now. So this is a valid approach. So I'll fix this soon. So find asset query settings. Why is the type cannot post it? Um, queries config back. I Oh no, this does not have to return. It's return. So are you complaining here? So compute raw movement now I need frame. I need the entity that we receive. Direction not default. Direction receive. We also pass in callback if we have one. Pass in layer mask. Received one. And finally, oh no. Okay. This pattern is valid here. Not gonna complain about it. So this one here is not, we don't have it yet. I'll talk about it soon. What is it complaining now here? Check here for questions. Okay. Questions. What is complexing which reference? Velocity. Ah, okay. Oh, this is static. This is part of the partial structure initializers. Explicit field initializer. Initializer. This thing complaining so much about my formatting options. I have a movement back same as the. Let's replace it with something. At a time. Static. The move method. Ah, okay. We need the pointer to the KCC. Oh no, we don't need this KCC anymore. It was part of the old. It's not. Oh, okay. Sorry. It's all good. So move the way it does here. I'm gonna modify this later after we have it tested by ported from the original. But the way it works by default is it does first a query, and based on the results of the query, it asks another method to compute the steering, which is you try to update the velocities and all the things, and then the steering defines the velocity at which we're going to move and so on. And then we're going to apply the movement, but we also apply the depenetration. Two different options. The penetration is bigger than the next one, we just snap the correction. Otherwise, we obey the penetration amount you want to do per tick, and we do that only. So, and in the end, we change the position of the character. Notice that this move does not apply any rotation to the character. That's something we always left to be done outside. So we're gonna do this manually later. Let's copy now the last missing piece, which is our raw steer, our steering method. Um, make sure it compiles, and then we can add um, add controls and test this thing. So let's see if this thing compiles. Looks like it's compiling right away, except it's not getting the config. And actually, we already have the config, so perhaps we should just pass it as parameter here. So frame, movement back, delta time, and a reference to the surface settings config. And we don't need to create this guy. Oh, but remember that I said that I wanted to use a different settings for the steering. Let's do that now. Let's create a different class for that. I don't want to reuse the old one. So I'll create one that I'll call C# script. It's gonna call that's query. So steering settings. It need to be a different one. So we'll grab the basic setup here, but we'll make it a different. So then close, and it will be called steering settings. The QTN, we're gonna add that as another type of asset settings, and we're gonna make the component have a reference to both. Settings. Let code generator work. So then we don't receive this thing because it's a separate config. So it's steering settings config equals frame dot find asset type steering settings dot id. I now know why it did not work with the original already inferred one. Is because we're doing it on top of this base frame type, which does not have the code generated goodies. And now we have to move the data that we need that we don't have from the other one. So funny, it also needs the gravity that's also used on the other settings. I'm thinking here if I should modify the other one to have a simplified gravity, or if I duplicate. I think this just needs to understand what the app vector is, and maybe I should just pass as a parameter instead. But that's any modification. So let's move these settings here to the one that needs them, which is this one here. Young comment. We have to add gravity as well here, but this should fix most of it. So we only need the gravity strength here. Notice that it's assuming gravity is on a single axis. I'm not making here a character controller that works for Mario Galaxy kind of game. So let me answer the question by stake here. So question is, what is frame thread safe? So internally in Quantum, we have a parallel task system that lets you use multi-threading. We don't, the documentation for that exists, but we don't put it publicly because it's not something that most developers need. But we do have the capability, and some things can be done in parallel. Like we can update entities in parallel. You can do navigation. You can do physics queries in parallel. You can, as long as you're very careful not to modify other things with queries. Um, you can even path find parallel using multiple threads. Um, but and it's very convenient the way to do. But there are some things you cannot do, like you cannot create entities in parallel. So that you have to do from a main thread system. But when you use a when you use one of these parallel systems that you inherit from one of the types, the system types that are parallel, what we pass in on the update method is frame thread safe, because this is the one that knows in which thread it is and so on, and you can and the queries work correctly in parallel. So this the version that so that's why all these methods have a version that receives the base frame, which is the one that the code generated frame inherits from, which is single threaded. But it internally actually uses this one because single threaded is a special case. Multi-threaded is the main case. So we implement it for multi-threading, and we expose both the multi-threading and single threaded version. Yeah, it's let's say dots and also has stuff running parallel, right? But it's a different purpose, but yeah. So I only need the gravity strength here. I'm checking. I'm thinking about doing something here because um, gravity strength could be something I add to the character controller, because you may want to modify that. For example, when jumping, sometimes it's nice to have a gravity strength when going up and a different gravity strength when coming down. So I'll already go ahead and use this speed. I'll just put here, so gravity strength, because you may want to modify this. So I'll make it mutable. I'll make it part of the component. And then it means that I don't have to use the gravity strength coming from the config. Mean that I don't have to add that to the config. It only uses the gravity strength. And it's all compiling again. But so we can play around. So for example, if we are in free fall, I can make this. But one cool thing to do, I'm gonna start playing around. But I'll let that to happen. Yeah, I always, so you guys can see that. Sponsored by Monster today. So yeah, we'll play around with this very, very soon. So let's make a better jump by playing with variable gravity. Let's put this to work, and then we'll do this. That's the next thing we're gonna do. It's the first cool thing we're gonna do by having access to modify the code directly as part of the project. So okay, cool. Um, now that we have the method, we can call it. So what is missing here? Frame. Oh, it's using the wrong type. It needs surface query result here, which is our new type. And the type here is this. Huh? I don't have. Oh, sorry. Smooth is this. Yeah, back compiling and with the right types. So it's the first thing we're gonna play with. So we have it all all compiling now. So let's now change our system not to call this, but instead it does not need the config anymore. It just needs to call directly kcc move, and we need to pass in the frame filter dot entity, which is self, default direction for now. But now it actually is going to perform the move as the original character controller by using using a capsule. So it should already work. And then we'll add buttons for jumping and for everything else. So let's play around with this guy. Move this guy up. Shall fall. Let's test it. Oh, it doesn't fall. We have an exception. Oh, yeah. I know why. Oh, I'm gonna. So we have a new setting now, steering settings. I'm not treating the default settings. So is it special? Specific type? Should be. Should not allow. Oh, this is the stating. This is the steering settings. This is type safe. Oh, I didn't create one. Let's create one now. Create quantum steering settings. Settings. Steering settings. Um, acceleration, braking, base jumping pulse, max speed, slope. Can use the config for this then. Air control. Okay, it's all good. And now this guy can point to, and it shall work. Save the project. And it's still not falling, but at least we don't have an error. So, well, oh, I know. Maybe I don't know, but I think I know. Oh yeah, I know. So remember, so this guy has two interesting things. He has the max speed and the gravity strength. And max speed normally comes from the config max speed. Oh, I think I comment. No, it comes from the steering config max speed. Max speed. But see that I'm not using anywhere. Same. So point is, I'm not initializing this value, and I'm not initializing the gravity strength either. So the original character controller has an init method. Let's make this. This is kind of, it has not been initialized. It has to be initialized. So let's create it here. Public void init. That we need just to pass frame. Then we'll have the version with name thread safe. It's not have the init frame thread safe, but you can always try to reinitialize it. So this calls it casting frame thread save. That's what you can. And this is the one that matters. So we need to grab the configs one, the other one. So the query the setting as well. Initialize two different things with query. So max speed equals settings speed to initialize, and gravity strength equals query settings dot gravity strength. Um, Now we can do something. here. So I signal added for character control. So whenever entity has this guy added, init expect it to work. Should be better on this. So frame should be a bit safer here. So query settings. Insert check query. So you cannot have this null. Emit and assert. If you call in it and this is null, I should add these asserts as well on the other one. I think the rest of the code is kind of protecting against that the no checks. But of course, the idea is to have an assert, so you don't fail silently. You actually show the error development. Don't make the mistake. So well, with all these set and initialized, should have it falling. Yes, it is falling, and the end we have velocity 0. A very little penetration because it was corrected, so we're not going to correct anymore. The normal is almost basically vector, the up vector, but we can do some cool tests now. So let's make this guy. So let me show something cool. So on our steering settings, on our query settings, our slope max is 60 degrees. So if the thing has up to a 60-degree angle, I mean the normal angle, it's not necessarily the I have to check if it's the angle of this guy. You will still stay grounded. If it's above that, you start sliding. So let's take a look at how this works. So if I get this guy and I put it at a 59, oh, not that, sorry, it's fine. So which one? Oh, this one that's rotated on Z. So if I put it 59 degrees, nice slope, and we'll move the capsule. Oh, that's pretty high. I think it's gonna. I think it's not that much. I think it's gonna already. I think I'm. No, it's actually it's 60. It's exactly where it still accepts it. So maybe it's too much on the config, but it's all the config. We can play around with that. So it's in 59. So if I put 50 max here, it should already slope down. Yeah, that's basically it, right? So if I play around with this guy again and I make this guy 50, I think it's exactly the right one. It still stays. Yep, stays exactly the value. As soon as we modify this guy to be 1, should already slope down. Yep, that's basically it. So you play around. Now let's make this guy move. I'll put it back to something like 15 down. Play around with it soon. But let's now add controls. So to have controls, we have to create let's create an input struct. We did this yesterday, but I'm gonna do it again. But I don't need shooting. I'm just gonna add a button for jump. I'm gonna add a FP vector 2 direction we're moving towards, and then let the code generator do its job. my movement system, instead of sending the direction and all that, it's actually gonna. Oh, we need a player link. Let's add the player link as part of the character control. No, I don't. Component player link. Just a second, guys. So that was Philip, our tech director. He was saying goodbye to go leaving for the holidays. So let's add a reference to our player here. Let's let the code generator work here. So normally a movement system does not need to know if a character is related to a player or not. Notice I'm not even using a transform here, but I still wanna I still I still wanna filter based on having the transform. But let's also get public player link, so we know this guy has a player. Although this is not mandatory. Normally you do a movement system agnostic to whereas there is a player controlling a character or not, as long as you have a direction and jump commands. But for simplicity reasons, I'm gonna do it here. So let's grab input. So this is equals f dot get player input for filter dot link player. So if input dot jump was pressed, then we're gonna do the dot kcc jump. Then we need to pass in the frame and we need to pass the impulse. But I noticed that I don't need to pass the impulse. I can query the impulse from inside there. So I can make it. Let's refactor this already the way it should be. So it should have FP. It's like this. Because what I can do is can grab during settings. So impulse dot. I have impulse, then impulse dot value dot raw value. Okay, as otherwise the steering settings dot base jump. So my mistake. Oh, raw value. Still with raw values. So then we don't have to pass any inputs. We'll just use the default one. Oh, you asked for something. So frame. Okay. I forgot to add the default values. Now it works for the jump. And instead of passing this, we'll just make this. So var direction equals input dot direction dot. I want to convert this to 3D, so I'm using the 2D version and using as XZ. But one important thing here. So it's important. So people could hack this and send like, oh, I want to send a direction that's faster, like a bigger vector. So this is very easy to solve. So this is above 1. Done. Solved. Nobody can send a bigger vector anymore. Even if they do, it will just be normalized to a one-sized vector. Now, instead of sending default, we'll send this direction here. So that's it for the simulation side to actually move in the direction we want. So now we need to link the Unity input, and as this thing is, we need to create. So as Jonas suggested to me, so we have this local input script here, that's the debug script. You should copy this and create another one that is nice to do that way. So we'll copy this guy here, not use it. Create a different Unity scripts for our game runtime. So let's folder here called scripts. Oh, they create a script. Yeah, aimbots is complicated, right? So not diving into the topic of aimbots. I'll explain what is repeatable is busy. Just give me a second. So let's create our custom local input. Local input color. Call it local input color. Local. So this that you're asking here is very, very important. So I'm going to explain this before inserting the input, grabbing the input data from Unity and inserting here. I'm going to explain what this is. So let's take a look at the session settings in Quantum here, how Quantum runs. So we have this thing here called repeat max distance and all the things about the input. So the way Quantum does prediction is locally on your machine, let's say you have the inputs for a certain frame, but you're always predicting a few more frames. So say if you have input for, let's confirm the inputs that you have from all players from the server for tick 100. And given your ping, you may be simulating ahead all the way to 105. So what does that work? So we have your actual input for all these frames because it's spawned locally. But what do we do for the other players? So what we do is we extrapolate their inputs based on the previous one they had. So we copy the inputs that they sent forward up to this limit here. So we don't, if you're predicting more than 10 ticks, we repeat the inputs of the other players up to the 10th tick, but the other ones we just stop copying. They're all other players except you are gonna have default zeroed out input used. So this is an overhaul. That's the main setting for this. But there is another clever thing we do with this setting here, which is what happens on the server if for one tick your input did not arrive on the server in time. We use this setting to replace your inputs for confirmed inputs on the server with the previous one you had. This is very important because it creates a very stable input even for you. So let's say you are pressing a button, but for one frame your input did not get to the server. That button is still going to be pressed. You are not going to have an unsafe state machine saying it was depressed and pressed again just for one frame. You actually smooth out and keep your previous input so the button keeps pressed until you actually release it. Because the server uses this configuration also to replace inputs for anybody who did not arrive in time with the previous value up to this distance. This is also important because it means that your local predictions are correct even if the other players have replaced inputs, because what the server replaces them with, it's with the same prediction you did locally. So it's kind of a clever trick we do. But this is only valid if your input uses this flag. So you still have per tick control to tell Quantum if the input of a player should be repeatable, predictable or not. So if you want to have an input that is never predicted, you can just not use this flag. And that's it. But the default and the thing that works really well is to have this. That's all what it is. Now let's go and add the direction here. So float x equals unity engine dot inputs. I always use the default input stuff. Get axis horizontal. Then we do this for y vertical, and then direction equals vector 2 p dot from float save x dot from float and save, then I dot jump, then equals t engine put dot get key. Not get key down, not get key down, because that only works on one unity frame. Pass always the current value. That quantum computer state machine, that all that I just explained is designed for you to have a smooth gameplay. Don't let Unity fuck it up. Oh, sorry. Don't let Unity mess it up. Um, I mean, it's not that what they're doing is wrong. It's just that it works well for single player. But when doing online, you want to have as stable as possible input coming up, and then you let the multiplayer engine play around with it and give you a stabilized state machine for the input buttons. So I want to check key code space for jumping. So we're now passing the input. We just need to use this script here in our local input pre-built object here on our demo scene. So we remove this one and we add our new one. Let's make sure this is not lost anymore. We should have a playable character now. No, we don't, because why isn't it should still be working? Error. Oh. Oh, I know why. So if you pay attention here, our movement system now expects player link component. Remember that I didn't like that? You know what? Let's fix that because I hate this thing. No, I'll leave it for now. But ideally, you should do it without this, and you should check if you have a player link, and then you create a direction and jump from the player. Otherwise, you still call the character controller move without a direction. It can come from AI or something, but in this case, I'm gonna leave it like this and just modify here, because what we have to do now is we have to make sure this thing has the player link component, and we'll go ahead and link it to the first player so we don't have to spawn this thing dynamically. And we have also to make sure our runner actually adds one local player dynamically, so we'll have control of one player, because we were running just as a spectator of the simulation up to this. So let's see how it goes again. And yay, we have control. We have jumps, can move around. I don't like this. This one I can try to correct. Switch is the it's super unstable. That's what I want to fix. Yeah. So, but before doing that, I wanna play around with the jump. So let's change the camera a bit. Where is this camera? Perhaps. Yeah. So this is okay for us to test. What I want to show is if we play around with the jump impulse, let's make this much bigger, like 6 or so. So the character goes much higher. But this jump doesn't look like nice. I mean, it's kind of too mechanic. And there is a very cool video. Let me try to find that for you guys. Paste the link. So I'll search here and I'll link the video. Now. So this is a great video. So building a better jump. And this guy shows super nice tricks of how to make jumps feel better to play. And I strongly recommend you guys to watch this video. So I'm gonna link it at the chat. Second, so other people can see it. And we're already. By the way, we finished porting the base KCC into source code so it can be fully modified. What we're doing now is we're already making it better. So let's start with the jump, because the jump it's kind of feels too mechanical. So let's start poking around with this and make it feel better. So we have error control on. Oh, the Unity something I don't like here, which is as soon as I deep press the button, the character is still moving a bit too much. It is not breaking with the breaking stuff only. This is because the Unity inputs for horizontal and for these, it's it's taking too long to put it to 0. I want it to reset to 0 very fast. Horizontal, vertical. I want it to set very fast. Save thing. So if I press right and stop, yeah, much better. So it's stopping now with the quantum settings for braking, which is already kind of, it's not like immediate, but it's much better than letting the Unity think. So don't do that. Don't use that. Always snap the input. The input is the player pressing or not? That's what you want to know. And then if it's not doing any input, it should be 0 immediately. And then your logic, your character controller takes care of the acceleration and braking. That's how you design it. Of course, if you have analog controls, you let people send a smaller vector. But as soon as, let's say, they release the thumbstick and the thumbstick is on the dead zone, you want it to immediately go to 0. You don't want Unity to do a smoothing down of the input for you. That's bad design. It should be part of your game, not of the setting. Games that they are known for having a great character controller, they always do this. By the way, do you guys see that how fast the simulation time is? Like 20 microseconds or so. Okay, so the first thing about doing a better jump is go to our steering methods here. It's to change the gravity when you're coming down. So when you're coming up, you use the regular gravity. When you come down, you apply a multiplier to the gravity. So what we're going to do is we're going to add an extra setting for the falling fall gravity multiplier. So if you keep this as 1, you would behave just like the regular stuff. But if we make it bigger than 1, they will fall faster. You can also make it fall slower if you want to do a gliding movement. So you can even think about this to be not only a setting, but actually have different states and so on. So that's why building a custom character controller is always so important. But let's just play around with the jump only here for now. So let's play around with just this for now. So what we do here is a branch. So if velocity y is larger than 0, then you use the normal gravity. So when going up, you use the regular gravity. When you're going down, you're going to use this multiplied by config dot fall gravity multiplier, because we're falling. So as soon as you reach the apex, you start using, let's say, default double the gravity. Let's see how this goes. We can play around with this, making the jump go pretty high and see how it feels by playing around with gravity. I do this even on car games. You make the gravity be different when you fall because it feels much better. So this already feels much better. Another thing that people like to do with this is that you try to make, you can also make the gravity multiplier start being applied as soon as the player stops pressing the jump button, because this way they can control how high the character goes, because if you just press once, it very quickly uses the stronger gravity. Press and hold, you use it all the way up. So let's try to modify to do that then. So we're already playing around with making this better than the default stuff. So we can do this, or we can make compute raw steer, and we can make bull jumping. So we can know if it's jumping or not, and it's right away the default for it is false. So what we do here is that either this or so we have to be positive and jumping for this to use the regular gravity. As soon as you're not jumping anymore, you start using the double multiplier. So busy. Let me explain a bit. So what I'm doing here is I'm just poking around the concepts of how this character controller originally worked and making a few basic improvements to it. So what we'll do is we can quickly share this code here. This code here, by the way, would work in Quantum 2 just fine. We can share all this even on in Discord. We can give you the source for these things here, because this would work fine in Quantum 2.1. I think a few things like the way I defined assets. So this thing here, I think this syntax is quantum 3, but you can use the same type of syntax with asset ref in lower caps. So you can use that quantum to 1. So the logic that I'm implementing can be done. But I'm doing this as a stream to discuss the concepts and show how you do these things. But what we will actually do is we're going to create a much more comprehensive character controller add-on in the style of the Fusion KCC add-on that will have the base character controller with I don't know, processors that you can add as a list of things on an asset, and they'll have transient state in them as struct. So we'll actually invite same lead developer who wrote the Fusion KCC to add to create that in Quantum, because he's also a Quantum developer, Iri and Irka. So they will jump in and actually create initially a simple version of it, but as extensible as the Fusion KCC. So that's the idea. And then you can add all sorts of crazy things like marking edges and so on by using processors and this style of the Fusion KCC APIs. But I'll start with this here. So we have this jumping. Let's make sure I pass in a jumping thing that comes. So I'll make this right before the KCC. Boolean jumping. No, no, jumping. It's false by default. On move, direction, callback, layer mask, direction. So if we don't pass jumping, it will immediately use the second gravity. But if we can if we keep passing the information if we're jumping or not, when calling move, it will actually keep going up. So what we'll do is we'll use this as the jumping information dot down. So is it still being pressed? So we'll keep jumping if that's the case. So let's see the difference that this makes. We can now let the player control how high the jump is. So if I press play here and I just quickly press jump, it doesn't go much higher, doesn't go much too high because it immediately applied the double gravity, so it doesn't go too high. But now I'm gonna jump holding. Oh, I made some mistake somewhere because it did not work. So let's see. We shall take a look. What was the mistake I made? It's actually it's probably on the logic. Live coding. That's what happens. So let's just review everything. So we have the input button. We pass is down, which tells us it's pressed or not. We can debug that. Let's see what happens with the pass is down. This is gonna be true. Pass into the next one, true. Jumping. I think. Oh yeah, I forgot to pass it to raw steer. Z fixed. Shall work now. Again, just touching would have the same result. Just touching has the same result. Barely touching, just short jump. Now I'll hold. Yes. So now I go much higher, but I still use double gravity when coming down, but only when coming down. If I just touch, I do short jump. If I press much, I go much higher. And of course, this is still, so it still plays with with the jump impulse setting. So if I put a much higher impulse setting, I can still have much more control. So the base jump now, even when I touch, even if I just touch, goes higher, of course, because the initial impulse is much higher. So goes pretty high. But then if I hold, it goes really high, really high. But then we can play around with this a bit more by using a gravity multiplier that's bigger. So 3 means that a short jump, it's pretty short because the gravity down is much, much faster. So there is a little bit jitter of on the deep penetration. We're gonna fix this next, so I'm gonna wait to get there. So that's gonna be the last thing. So, but now if I press high, it still goes super high, but it falls down pretty fast. But I think this is a bit too much. 8. I think 6, 7 is kind of nice for this type of proportions we're playing with here. So we have quick short jump or go a bit higher, regular gravity. Now, of course, you can still. This is how you do a platformer kind of thing. Of course, camera, everything, relative control, all plays a role here. But I strongly recommend you guys to take a look at the video I linked. It's a really, really good video. Okay, let's now fix this annoying thing here with the depenetration and with these vibrations and so on. So what is wrong here with the default KCC is that one of the things that's not so good is that what we're doing is we're querying where we are right now, then we apply the movement and we let the new position be rendered, and the new position may be going in something and is not applying a correction on it anymore. So there are a few ways to fix for this. So let me give you an example. So you can, the way it's working now, it says it performs query, then moves moves, then it renders. So moves and penetrate with the previous position query. So this is kind of bad. So there are two ways to do this and fix it. So one way is to do this and do a secondary query just to depenetrate. And so we can not depenetrate and just depenetrate with a second query. But that uses two queries, which is expensive. There is another way to do this, which is what I want to try here live. So the idea is to perform movement with current, velocity, and surface tangent. Then shift. Then perform query on new position. Penetrate and cache the query result for next tick. Because then when we're going to perform movement, current velocity and cached result. Because we need the cached results to perform the velocity update. So this idea here still uses one query only, but the render is going to happen after the depenetration at the current position. So we should not have the vibration of going in and out only on the next frame. So let's try that. So we already have, the cool stuff is that we already have the cached, um, we already cached the last query result here. So we can use this guy to compute the steering. So for me, it is as easy as, I think so, as easy as move this guy here, and we'll pass as reference this guy. Um, then we do the query at the current transform position, but we have to, so we computed the steering. We have to perform the movement without the depenetration because we're going to do the depenetration last. So what we're going to do is we're going to first, right after steering, we perform the first part of the movement with this. So we perform the surface movement, which is the movement that the character wants to have. And then we compute the query again. We actually don't need this, we can just cache. This is a simplification of the previous code. And then we do just the depenetration. We set the movement, or we can even call it FP vector correction fault. And what we do is add here. So this is just a so this is my idea. Let's try and see how it works. So where did I add the code? Oh, in the system. So the move call is the same, but it is now doing this. So let's see how this feels. Oh damn, it's already bad. So I don't know if you guys notice. I think the stream is going at 60 hertz. I hope it is, because there is no penetration on the floor anymore. So it never glitches in the floor anymore. Always stops at the surface correctly. So I'll try soon. I have a few check. Check. Sorry. So it's still running. So let's see how it goes here. Oh damn. Oh, it still has the glitch, but I think it's because we're not depenetrating everything. It's still going bad when going down. I have to debug this one, but going up is already much better. So let me think a bit. I think it's just because I'm not depenetrating full. Let's try to depenetrate full all the time. So yeah, you can always do penetration correction 1. Settings, penetration correction half. Let's full. See if it becomes correct. It doesn't. I'm not gonna bother too much. I'm gonna. Yeah, it's still not perfect. It's still. I think. be that this we're using. Oh, I don't like this byproduct. It's not resetting. See that there are byproducts of this. Of course, I can try the double dip. Oh, I know. Because this is the deep penetration pass. And when you're doing no movement, I should not do the deep penetration pass unless I'm higher than some values. Okay. Because it is constantly adding a deep penetration, falling again. Okay. This explains. But this, I don't have an explanation. I have to fix this one. That will have, it's getting a bit late, so that will have to go next. So I just want to try two things. Next gravity. Oh, it's because I'm applying gravity. I have to be careful when first. So Rosti, huh? See if it's why do you so let's fix on the move. Max pen this is the max, not allowed pen setting for that goes instant. Um just thinking loud a bit how I can fix for I can check that I'm only fine. It's bigger than this, but treat it by the fraction. Or maybe it's because I added the one here. Adding 0.9 allow it to stay have to I think it's stable. Yeah, stayed. Yeah, that was it. So I have to have a known penetration. Fault should only penetrate those above us. This is stabilized. Yeah. So it stops at this low expected. That's nice. Okay, so that was idea. expected. But this one here, I'm not yet 100% sure why it happened. I'm not. So what happens here? So we have ground normal positive, zero con. Why can be ground normal? Oh, touching enough, but we free fall. The next tick, adding velocity. Then we touch. Have a pretty much a positive the correction. Tiny. Then on the next tick, oh, rejected. That I think that was 0.2, right? Try one more. The allowed penetration below this in 0.9 of the that should not uh, have very tiny penetration. This is even below EN3, so it should not be corrected, I guess. Very no. Oh yeah, it's already stabilized. Let's do it again. See if we get. Oh yeah, we got the free fall. So we are touching, and penetration is below. Should correct. What is the velocity? Is of not setting the y part of the our. Okay, there is. I have to debug better to find this. It is on time to see what is the velocity component I get compared to the surface. Okay, so I have no velocity set my engine, and I still I am resetting the correcting some. Let's see if I have any. Um, I am not really tired, but starting to become a bit. So maybe yeah, that I'll probably. But what's bothering me is that I know that this here for some time, and a lot of customers, because we share this code with anybody, so they have their own implementations that are, of course, much more complex, and they fix all this. But I wanna find why and fix lub factors. What do we do with the y component? So number unknown. Yeah. Okay. It's so we have velocity on this y value. Oh, we're lerping. We're lerping. Shouldn't it be? Oh yeah, it's very small. That is. We're jumping with touch. I'll try some. Check a few. Let's see how it goes now. Tapping or stable, stabilizing on the slope. Good. Vibrate here. Like uh, I, I, I'm afraid I'll not be able. I know it has to do with the two facts. And before you guys ask, do we do pay attention to overlapping corrections? So we use dot products and we only apply the amount of correction that's necessary. Already applied correction. Same. That develop high value accents have up. Actually, it's trying to come down, but because we're in type no, that is. But okay, I know what the problem is because it is somehow getting the nearest normal, the nearest that is getting the contact of the ramp, not the contact ground here. That should that should not be the case. Ground. Oh no, I have center. Center should be the closest. The thing that they are very distinct. Definitely effect on the flat ground should be why it is the nearest normal, the one that's not up. Fortunately, I think Daniel went went out to have lunch, but I'm gonna ask this back. I might write this down on chat on Discord, but I think the problem is that we're getting the contact with ramp as the first contact, it should not be the case. First contact close to the ground, and that would put a really positive by gravity on direction. It's touch. Tricked by this. The sphere version does not have this, but I'll have to find this off camera and answer right down on Discord later. So on one topic here about yesterday's stream for those who watched it. So I actually finished off camera the snapshot interpolation part. So we have verified frames being rendered, and I updated the back for the light compensation to send the correct offset what is by the snapshot interpolation timing. So the light compensation uses that instead. Polished a few more things. So I'm gonna do a bit more off camera, but I expect to stream about this again, like compensation on quantum, um, early January when I'm coming back from holidays vacation. So I plan to go back to that and stream about it again, but not today, not tomorrow, not not next week. Next week we're mostly off, so I don't think I'm gonna do too much anymore on this for now. It's basically the time I expected to finish the stream. So just a quick recap: we made this character controller code that was basically in the SDK to be a component that you have full control of directly with code generated types, um, custom implementation that you can modify at will. So we demonstrated that by making jump feel much better than before. And we also implemented a nicer system for the snapping of the correction. It's still not working on the multiple collisions. I will investigate why, because that is not to do with the new approach of first moving then depenetrating. That is good. What is somehow wrong here is there is an overshoot in some cases, and I need to fix for that. I don't know why it's back for it. Sense why it is. So round normal, negative, positive, free fall. Why is it correcting positive? Corrected side. Oh, the correction is positive. You're right. Some there is an off by something here. This value here should never be positive because the normals are all negative on the x. That okay. Oh, got a positive. Dang. Right again. Click. Bang. Positive correction. There is one node that is getting a positive X here, which for me doesn't make. Huh, okay. We'll investigate this. Find what's wrong, but it looks like there is a normal that's being perhaps bug. Try one thing. I don't expect this to be the case, but just try something. Try to use C sharp version of the. I don't think it's the same. They are binary compatible. Whatever the bug is, it's there. I think this is a bug that's not in this code, but could be. But I'll investigate this off camera, and I'll talk to the other guys, and I'll give an update on this over Discord. And because I think the approach I'm using here for the first move and then later by the correction is the best with one pass. Uh, and it will be a matter of fixing why uh, this normal is coming positive X. It should not have a case for a positive X in this call because that is causing the patient to uh, shoot correction, and that's what's causing the whole. But I'll update that on Discord. That's what I wanted to show for now here about this topic. As I said, if you guys want to have this code, I can share it. It's fine. And it will be much improved. A proper KCC add-on early next year for people who have access to course Quantum 3. And but yeah, it will eventually be. So this is was it. So hope you guys enjoyed. See you guys next time for round to see questions. Thanks a lot for watching. This video is gonna be immediately available publicly, so you guys can share. Um, it's if topic you tell them about publicly list our YouTube channel. Yeah, you should subscribe. We'll try to do a lot more of these next month. Hey, again, thanks for watching. See you guys next time.